Hi everyone, this is an exercise 14 in question 5, and in part A we are given this equation and we want to show that um, this is basically equal to 3x squared minus 7x plus 2 is equal to 0. Okay, so we need to use log laws to simplify this logarithmic equation and convert this into a simple quadratic basically. So we can first start by rearranging this equation and have all the logs on the left hand side. So log base 3 of x plus 1 minus 2 log base 3 of x minus 1 is equal to 1. Right, so now that we have all the logs on one side, this is basically when we have subtraction and the base numbers of logs are the same. This is the division law, which allows us to combine these and just write them as a single log, in which we have the first basically expression or number divided by the second expression. So in this case, one thing just before that is this 2 here that we have. So we should be careful because in terms of the power law of logs, we can basically write this as a power of the number inside. So we are allowed to kind of take this power and just we can write that as a coefficient of log, or if it's a coefficient, then we can just bring that back inside so that that's the power of the number expression. Okay, now that we have in this form, then let's write this as log base 3 of the first expression, in this case x plus 1, over the second one, which is x minus 1 squared is equal to 1. Right, so at this point, we can just do a simple, basically we can use the definition of log, which says that the base number raised to the power of this number outside is equal to basically what we have inside. So that's x plus 1 over x minus 1 squared. And we know that 3 to the power of 1 is just 3. Now we can just do a simple cross multiplication, and that gives us 3 times x minus 1 squared is equal to x plus 1. Now let's expand and simplify. So we'll get 3x squared and minus 3, actually positive 3, and minus 6x on the left hand side, and simply x plus 1 on the right hand side. So we can simplify further. We have 3x squared on the left, and then to keep everything on the left hand side, minus 7x and plus 2, which is equal to 0. And this is exactly the form that we wanted to show in part A. Now in part B, we want to solve this equation basically. So we've already done most of the work. We just now need to solve this quadratic basically. And this is basically a simple factorization. And we can also use the quadratic formula, but maybe it's quicker to use the factorization here. So we use the AC method. Because the coefficient of x squared is greater than 1, we can multiply 3 by 2, which is 6. So we want to find a pair of numbers that they basically add up to minus 7 and the product is equal to 6. So that's simply minus 1 and minus 6. So we can do 3x squared minus 6x minus x plus 2. And then we can separate the first two terms so that we can factorize them and then have another pair of here. So for the first pair, we take a factor of 3x, so this becomes x minus 2. And then for the second pair, so we take a factor of minus so that it becomes x minus 2, because the goal is to have the both brackets to be the same. And now we can do another factorization, which is 3x minus 1. So it just here, because this minus is the same as minus 1 times x minus 2 basically. So this is the factor. And now if you want to solve this, because the whole point was solving this equation basically, so we set the two brackets equal to 0. First we have 3x minus 1 is equal to 0, which means x is equal to a third, and second x minus 2 is equal to 0, which means x is equal to 2. But one thing to be careful in terms of choosing the final solution is that in terms of our equation, the main equation, which has logs, so as you can see here, we have x plus 1, which is fine, because if we add 1 to any of these numbers, we won't have any issues, right? Because we'll have a positive number. So 1 plus 1 over 3 is 4 over 3. That's positive, and 1 plus 2 is 2. But when we look at the second term, or the second log, we have x minus 1. So if we substitute 2 into that, 2 minus 1, that's fine. It still is 1. And log is defined for the value of 1. But if we substitute 1 over 3, then we'll have 1 over 3 minus 1, which is minus 2 over 3. And this is undefined because log only accepts the values of x which are non-zero and well, which are actually positive. So that means this value of 1 over 3 is problematic because of the reason I just explained. So we only accept this solution since for log x always has to be positive, right? So if we pick this value, then we'll have log of x minus 1, and 1 over 3 minus 1 is not positive. So yeah, the only solution is just x is equal to 2.